In the last video, we understood what is meant by addition or how our addition we are going to prove. So in this video, we shall give a logical approach. In the last video, we just gave an intuitive approach. So in this video, we shall give a logical approach to the now our definition of addition. So our definition of addition. Before that, saying it is a definition of addition, we just define what is meant by alpha plus beta. Okay. So how here our alpha and beta are cuts. So since we are dealing with those things, okay. So our alpha plus beta is a set of all rational numbers. So r plus yes. Here this plus is an addition. Okay, addition of cuts. Okay, here this is our well-known uh, addition of real numbers, sorry, rational numbers. Okay, so r plus s such that it is a set of all r plus s where r and s are rational numbers in such a way that r belongs to alpha and s belongs to beta. So let us understand what is this means. This is a set of all possible ideas. So for this I will give different example. Okay, say a is equal to 1 2 3. Okay, b is equal to a b. If our addition is a plus b is defined like this, uh, x plus y such that x belongs to a and y belongs to b. Okay, y belongs to b. So how, what are the possibilities? Here our possibilities are not possibilities, sorry, answers are 1 plus a, and then you do 1 plus b, 1 plus c. Okay, then 2 plus a, 2 plus b, 2 plus c. Similarly, c plus a, sorry, 3 plus a, 3 plus b, and 3 plus c. That is all possible pairs of addition we are doing. Okay, so this is the meaning of it. So you can imagine there are a lot of rational numbers, infinitely many rational numbers are in alpha and beta, and we are doing them, and intuitively we know what it will be. Okay, so let's go further again. So our next challenge is to prove this alpha plus beta is a cut. Then only we can relate it with the addition. Why? Addition of two real numbers will give us the real numbers. So first and most it should be a real number. To be real number it should be cut. Okay, so how to prove this? So, simply by making one more effort to prove the three properties. Okay, so first property is like this, right? We should prove this alpha and beta are not null sets, as well as it should be this proper subset of the rational numbers. So how to prove it? Well, it is very clear this part, right? Because alpha is a cut, that means it is not a null set, and beta is also a cut. This means this is also not a null set, and alpha plus beta we defined as r plus s, where r and s belongs to r belongs to alpha and s belongs to beta. So there are an r and s such that r plus s belongs to alpha plus beta. This is very clear. Okay, this part is very clear. Coming to this part, uh, how to prove this? Okay, let us note what are things we know right now. So those will help us. We know alpha is a cut, right? So alpha is a proper subset of real numbers. This means there is an r dash belongs which there is an r dash which not belongs to alpha. This r dash is a rational number. Alright, there is an r dash or there is a rational number which is not in the alpha. This means what? This means our r dash is greater than every element of the alpha. So this is one of the property. We can we can get one more. Beta is also subset of rational proper subset of rational number. Therefore, there must be some s dash, okay, which not belongs to beta. This means this should be less than this should be less than every s dash. Sorry, this s dash should be greater than every s which belongs to beta. All right. So what is see how our r plus s, r plus, here r also belongs to alpha and s also belongs to beta. Here our r dash not belongs to alpha and s dash not belongs to beta. So what is the thing is our r dash plus s dash does not belong to alpha plus beta. This is clear. And also r plus s is always less than r dash plus s dash, which is not belongs to alpha plus beta. That means for any pair of s, r and s, we can find this r plus s dash which not belongs to alpha plus beta, and also it is greater than. That means we are always, if it is our alpha plus beta, we are finding r plus is dash always outside. What that means? That means we have a rational number. That means we have a rational number r dash plus s dash, which is not belongs to alpha plus beta, but r dash is a rational number and s dash is a rational number, therefore this is a rational number. So we have a rational number which is not in the alpha plus beta, but alpha plus beta is a subset of the rational numbers, because every r plus s is a rational number. So what that means, our alpha plus beta is a proper subset of the rational numbers. So clear, from the very trivial information we got, this one alpha plus beta is not a null set, and now with this effort we are getting this means the first property satisfied. Alright, so coming to the second property. So coming to the second property, what second property says? Let p is equals to r plus s. Okay, let p is equals to r plus s, which belongs to alpha plus beta. Okay, simple note here, r belongs to alpha and s belongs to beta. If p is a rational number, and if there is if p is a rational number in the set, and if there is a rational number q less than p, then q must also belongs to this alpha plus beta. This is our second property. This is what we are going to prove, right? So now let us take q is a rational number which is less than p. All right. So this is r plus s. So we will get q is less than r plus s. So this will give us q minus s is less than r. Fine. What we can do now? So this our q minus s is a number which is a rational number less than r. What is this r? This is a number in the alpha, and this is a rational number. Therefore, our q minus s belongs to alpha. Now you can write q as q minus Yeah, q minus s plus s. This q minus s, here we have it. This q minus s belongs to alpha. This s obviously belongs to beta. So we can look this q as sum of rational numbers. First rational number belongs to alpha and second rational number belongs to beta. So you give us any rational number less than p, that is r plus s. We can find out one more rational number depending on the s, q minus s plus s, such that our q is also belongs to alpha plus beta. This shows us that our second property to be cut is done. So the third property, we should show that there is no biggest number. Okay, to show that, let p is equals to r plus s is a number in the alpha plus beta. So what we have now, we have a number in it. So we should find out one more number greater than the p, but it is also in the alpha plus beta. It is very simple because this alpha is a cut. So there should be a number t in the alpha such that this r is less than t. So this implies r plus s is less than t plus s, and t is a number in the alpha and s is a number in the beta. So t plus s belongs to alpha plus beta. So we can, if you give us r plus s, we can find t plus s, which is belongs to alpha plus beta. So clearly third property also satisfied. So what we have now is very important and beautiful thing, that we have alpha plus beta as a cut, that is, it's a real number. So with our definition of addition, we can get, by adding two numbers, we can get an real number. I mean, once again, cut. So it is closed under our operation, that is addition.